Welcome to Evaluating Limits Algebraically. In this video, we're going to go through it 3 different ways. So first of all, to evaluate means to calculate the numerical value of something. So when we're talking about evaluating a limit, we want to know what it is equivalent to. Now, there are 3 ways to evaluate a limit, and those ways are through substitution, factoring, or the conjugate method. This video is going to walk you through each way. Keep in mind you could also evaluate limits graphically, like in the previous video. So the first way is substitution, and it's pretty simple. You see that we're trying to figure out the limit here as x goes to 0. So what you're going to do is plug 0 in, and now we're going to get 0 squared minus 1 over 2 times 0 plus 3. If you put that in the calculator, you're going to be getting -1/3. Now, you don't want to take this answer for granted. What you want to do is definitely either check with the table on your calculator or look at the graph. Actually, doing both is best. So I have my calculator and I inputted the function, right? I'm going to go to the graph, and remember that we were talking about the limit as x goes to 0. So looking at x equals 0, the y value does appear to be -1/3. If you look at it coming from the left, we're approaching -1/3, and if you look at it coming from the right, we're still approaching -1/3. So everything seems to work out. But keep in mind that you want to check the table just to make sure everything is good. And at 0, you do indeed come to -1/3. So because the table and the graph checks out, we can say that this is confidently our answer. Now, if you look for the second one, as x approaches 2, the substitution method won't work, because look what happens when you try to plug in 2. Right? So up top, you're going to get 0, and on the bottom, you're going to get 0. Now, 0 divided by 0 is not 0. You can't divide a number by 0. It does not work like that. So the main thing is that this doesn't work because you get a 0 in the denominator, and that is not good. So if you can't substitute, you have to use a different method. And what you can try to do is use the factoring method. Now, you can factor the top using the AM method. So this is going to go to x minus 4 times x minus 2, because -4 times -2 multiply to +8 and add to -6. And then the bottom's going to stay x minus 2. Now, we can simplify this function, right, by crossing out what they have up top and on the bottom. And you're going to be left with x minus 4. So now, instead of finding the limit of the original equation, we can condense this to finding the limit as x approaches 2 of x minus 4. Now you can actually use the substitution method. You could plug in 2, and you're going to get 2 minus 4, which is equal to -2. And you're going to get your answer. Now, if we go to actually check our answers in the calculator, check out what happens. I have my new equation in the calculator, and I go to graph it. We're trying to find the limit as it approaches 2, and if you look, as we approach 2, it does look like your answer is going to be -2. However, we know that you can't really plug in 2, so what happened with the equation if we don't see anything wrong with it on the graph? Now, your calculator does not show you holes on the graph, right? This is what's really happening. There is a hole in the graph at x equals 2. So really, what this graph should be looking like is this, where at 2, there is a hole. But remember that the limit still exists because you are approaching -2, not necessarily equaling it. And you can see that there's a problem here if you go to your table, right? At x equals 2, there's an error where the hole is. So just because you can't see the hole on the graph, you can see the hole in the table. So I suggest you pause the video and try to find these limits on your own. When you're done, you can resume the video and check your answers. For the first one, if you plug in 2, nothing strange happens, right? There is no undefined value or anything like that. So yes, you could factor this, but you do not have to. So we're going to plug it in normally. When you do plug in 2, you end up getting 14. So that's your limit. Again, make sure you check your work in the calculator, the graph, and the table to make sure it is correct. However, it's going to work for a polynomial because all polynomials are continuous functions, right? There's no discontinuity within the functions. So I know that my plug-in method, the substitution method, is going to work because these are constant functions. What's probably not going to work is down here. These have points of discontinuity, which means you definitely should check in the calculator because something can go wrong. Anyway, I'm going to plug in -1 for the next one. Please make sure that when you put it in your calculator that you include parentheses around the negative, or else your calculator's not going to calculate it, right? And if you're not getting the same answer as me, this is probably where you went wrong. But I got 10. Now, number 3 is a rational equation. Sorry, rational function, because you have fraction. And if you notice, if you try to plug in -3 in the bottom, -3 squared plus 3 times -3 is 0. So we can't substitute because it makes the denominator undefined. What you can do is factor with the AM method up top. That's going to bring me to x plus 3 times x minus 4. And then you can use the GCF of x on the bottom. So you pull out the x and you're left with x plus 3. From there, your x plus 3's cancel out, and you're going to be left with x minus 4 over x. Please be careful. You cannot cross out the 2 x's. It doesn't work like that. From there, you can evaluate this new limit. So we have the limit as x approaches -3 of x minus 4 over x. Now you can actually use the substitution method. That's going to give you -3 minus 4 over -3. Overall, you're going to have positive 7/3 because a negative over a negative cancels out and becomes a positive. Let's try number 4. Again, if you try to plug in -2 into the denominator, I don't really care about the numerator. If you try to do this, you're going to get 0. So because it makes your denominator undefined, you have to go with the factoring method. So I have x plus 3 up top, and then with the AM method of factoring, the denominator is going to turn into x plus 3 over x plus 2. the x plus 3 over x plus 3 reduces to 1, or cancels out if you like to say it that way. And just keep in mind, because you canceled out the x plus 3 doesn't mean there's now nothing up top. It reduces to 1. So we're going to replace it with a 1 over x plus 2. That means we can rewrite the limit as x approaches negative 2 of 1 over x plus 2. Now we can use the substitution method. Actually, you still can't use the substitution method because if you think about it, 1 over negative 2 plus 2 still gives you a 0 in the denominator, and that's not good. So sometimes this method doesn't work for you. And now you have to think about how to actually go around it. So if you can't evaluate the function by factoring, you can use the graph. So let's use the graph here. I'm just going to tell you that the graph of the function is going to look like this. That's what you would see if you had it in your calculator. In order to figure out this limit, what you're going to have to do is find the limit of 1 over x plus 2 as x approaches negative 2. Oops, I'm running out of space. From the negatives, and you want to find the limit as x approaches negative 2 from the positives. You want to come from the left and the right, like in the previous video. So from the negatives, coming from the left, we head downwards. So I'm going to write negative infinity. Coming from the positives, right, going right to left, we're heading upwards, which is positive infinity. But because one is negative infinity and the other one is positive infinity, they do not match. So what you're going to do is write does not exist, DNE. Because at negative 2 on the graph, you have an asymptote going on. And this asymptote, unfortunately, they're going in opposite directions, so that type of discontinuity doesn't allow us to actually have a limit. Let's go on to the last method in this video. So we have the conjugate method. Now, hopefully we remember what a conjugate is. So if you have the square root of x minus 4, the conjugate is going to be the square root of x plus 4, right? All you're doing is changing the sign in the middle. That's it. So now here we have the limit as x approaches 16. You can't plug in 16, so the substitution method's not going to work because 16 minus 16 is 0. You also can't factor because, well, none of this can be factored, right? So instead, we need this method. And this method is really useful when you see radicals within the functions. So here we have square root of x minus 4. What you're going to do is multiply by the conjugate. Now, what you do to the top, you want to do to the bottom. Now, notice you didn't really change the equation because something divided by itself is equal to 1. So you're technically multiplying by 1, which isn't messing anything up, but it ends up working out. So if you were to actually go and multiply this all out, if you did want to multiply the top, technically you would need the box method, right? So you would have to do square root of x minus 4 times the square root of x plus 4. You can't just multiply the square root of x times the square root of x and negative 4 times positive 4. It doesn't work like that. You would have to use the box method in order to do it all out. However, the nice thing is that with these problems, it does always work out in a nice way. So we're going to erase this because you can just remember the trick, or you can go and do it by hand each and every time if you prefer extra work. It does happen to work out nicely with this method that you're always going to have plain old x, the radical will go away, minus, and you're going to square the number, the constant. So I'm going to have x minus 16 because 4 times 4 is 16. Now in the bottom, I still have the x minus 16 times the square root of x plus 4. And now the square root of, sorry, no more square roots, we got rid of them. X minus 16 cancels out with x minus 16. You're going to be left with 1 over the square root of x plus 4. Now that we simplified our function, we can now go back to an easier method. Notice that before you couldn't plug in 16 because 16 minus 16 is 0. But now we could plug in 16 because it's not going to make the denominator 0 in this new function. So I'm going to rewrite the whole problem. The limit as x approaches 16 of 1 over the square root of x plus 4. That's what I came up with here. I'm going to substitute the value in, and I'm going to have the square root of 16 plus 4. That gives me 1 over 8 if you were to simplify it. And that's my answer. So basically the goal of finding limits algebraically is try to substitute it. If substitution doesn't work, then try to factor it or try to use the conjugate method to reduce it to something where eventually the substitution method will work. And if substitution still doesn't work in the end, like in that last example we did on the other page, then you can go to your calculator. Let's do one more problem. Now, notice in this problem, you can't plug in 0 because, well, I mean, then only 0 would be in the denominator, and that's not good. I also can't factor anything. But I do see that there is a radical in here, so I can use the conjugate method. So I'm going to multiply both pieces by the conjugate. Now, the conjugate is going to be the square root of x plus 1 plus 1, because what I'm doing is switching the negative outside of the radical. You don't want to switch the sign inside the radical. So always switch what's between the radical and the constant. Now, when you do this, we said before that this makes the radical go away. So it becomes just x plus 1 minus, and now we're going to square 1. Negative 1 times negative 1 is, sorry, negative 1 times positive 1 is negative 1. Now, if you don't believe me, you can do the box method and find out for yourself. On the bottom, I have x times all of this that we're multiplying by, the square root of x plus 1 plus 1. And now I'm going to work on simplifying things. So up top, plus 1 minus 1 reduces to 0. So that's going to be x over x times the square root of x plus 1 plus 1. When it comes to the conjugate method, you never want to actually multiply the bottom out because it always ends up canceling nicely. So if you do multiply early, you're just going to have to factor again, which is time consuming. So here, like I said, it ends up canceling nicely. The x's cancel out. And you're going to be left with 1, right? Because there's nothing left up top. So it reduces to 1 over the square root of x plus 1 plus 1. Now that we have that, we're going to rewrite the whole question as the limit as x approaches 0 of my new function that we just got. So I have 1 over the square root of x plus 1 plus 1. And now you're going to use the substitution method. So I have 1 over the square root of 0 plus 1 plus 1, which when you put in the calculator, you're going to get 1/2. And there's your answer. So keep in mind when you're doing these problems that you always want to try substitution first. And to check your answers to substitution, use your calculator, look at the graph, and look at the table to make sure that you're right. If you can't use substitution, try factoring, in which case then you can use substitution afterwards once you factor and cancel. If you can't factor and if you see a radical, try and use the conjugate method. And even once you use either the factoring or the once you use the factoring or the conjugate method, if substitution doesn't work, then you can resort to the calculator, look at the graph, and try to figure out, does the limit exist here or not? And that's all for this video.